Hello everybody, welcome to Algebra 2 videos for the day. We're looking at 17.2, which is factors of polynomials. Here are your learning targets. Okay, I'm going to be going through several cases here on factoring. So we're going to look at several cases, and I've highlighted the names of the cases up here. In this case, we have difference of perfect squares. We're going to run through how to use a diamond in a box. We're going to run through factoring by grouping. We're going to go through difference and sum of perfect cubes. And finally, we're going to look at cases where we have to factor out a common factor before we apply one of those methods. So let's start at the top here, difference of perfect squares. This should be a review from Algebra 1, but as it goes, it's always good to kind of cover and just to make sure. Difference of perfect squares, you can identify them because they have no middle term. There's just kind of a first piece and a second piece, and it's a difference. So we're doing a subtraction problem. Now, they have to be, obviously it says choose squares. So as you look at this, I do have perfect squares here. I've got 81 as a perfect square, 9 times 9. And then I have x to the fourth as a perfect square because x squared times x squared. And then I have 625 because 25 times 25. Okay, so that's how you recognize the difference of perfect squares as we go to do our work here. All right, so they have to be perfect squares and they have to be a difference. We cannot apply this method to something that looks like this. Okay, so we cannot apply this method to if this was a plus in between because your middle terms wouldn't cancel and it wouldn't work. Okay, so let's take a look at what we do. The pattern is right here for us. It says that we just need to write it like this. So the first thing we need to do is identify what A is and what B is. Now be careful, I'm not saying what A squared is. We know A squared is 81, so what's the number that gives that square? Well, it's going to be 9. And then for our B value, it's not B squared we need for the factoring pattern in blue up here. It is the square root of that. So 25 is our B value. And once we determine those two things, we just plug it in this pattern right here. All right, so we say A squared minus B squared equals, notice we're going to have a plus minus, and I'll explain why that's happening. So we're going to put it says to put our A plus B, so 9 plus 25. And I forgot one thing for our A. It's also x squared. So it's 9x squared is A. So we're going to have a 9x squared here plus 25 and a 9x squared minus 25. And why does that work out there? Well, if we go back and multiply them back together, watch what happens to the two middle terms. So I have 9x squared and positive 25 and 9x squared minus 25. Of course, top right is going to give us negative 625. Bottom left will give us 81x to the fourth. And then we have these two pieces in between. Our two pieces in between that are going to cancel. This is going to give us 2, so 225 x squared. And then down here, negative 225 x squared. So you can see when we add those two, our middle terms cancel, leaving our final original piece there. So difference of perfect squares. Be able to recognize it and almost factor it in your head, really, once you see enough pattern. Okay, so our next pattern here, I want to focus in on what we call quadratic form. So if you ever hear quadratic form, think diamond in a box, okay? Now, in this case, I want to look at this problem over here to the left. We don't necessarily need the diamond in the box because it starts with just x to the fourth, but I'm going to go through the process in case you get a harder one where it has a number out front. Like if you had, 25x to the fourth instead of x to the fourth, you would definitely need the diamond in the box. Again, for this one, we know it's going to split up x squared and x squared. But let's go ahead and show the diamond just to review. And again, if I put up here a note, if you need to review the diamond in the box, we covered that in section 7.2 and 7.3 from quadratics. So you can go back and review those videos if you need to. Okay, so let's look at our first diamond here. Remember, we're going to do first times last to get the top of the diamond. So that's negative 20 x to the fourth. And we put our middle term down below. So that's 1x squared. Now we need two numbers that multiply to negative 20 but add to 1. So in that case, we're going to have 5x squared and negative 4x squared. Because when I multiply those together, I get negative 20x to the fourth. And when I add them, I get positive 1x squared. Now we call it a diamond in a box because now we need the box. So remember, in the bottom left, we're going to put just our first term, which is x to the fourth, and our last term. So notice, just to reiterate this point, we're using the first and last here, and we're using them here. Here we're using them together in the top of the diamond. Here we're splitting them apart. Okay, so now let's put in the rest of our pieces here. So the sides of the diamond, the reason we did diamond is so that we know what goes here. This is 5x squared, and this is negative 4x squared. Okay, now we're going to focus on the top row up here, that row. What's in common? Well, we have a 5 that we can factor out there. So we can factor out a 5 between 5 and 20. And down here, we can only factor out an x squared. Here, same thing, an x squared. And here we have negative 4. And remember, when the whole column is negative, that's how you know where to put the negative. Okay, so our final factors are x squared plus 5 times x squared minus 4. Now, we're almost done with this one. This one actually has a difference of perfect squares within it. So a lot of times we have to do 2 levels of factoring. So the x squared plus 5, there's nothing I can do with that one. But remember our difference of perfect squares that we just covered. This right here is going to factor as x plus 2 and x minus 2. So in this case, this has 3 factors for this problem right here. Okay, so we had to do 2 different methods, and a lot of times with these factoring, that's what we're going to have to do. I started with a quadratic form, which is the diamond in the box, and then I got it to the stage where I'm on a circle in green. Got to this stage and realized that the x squared minus 4 splits up into these two. So our final answer is in this bottom circle. Okay, let's focus on this problem over to the right. We could certainly use the diamond in a box from this right here. It would apply. But what you'll have is you'll have the missing middle terms gone. Let's just recognize this is a difference of perfect squares because 16 is 4 times 4. 81 is 9 times 9. And x to the fourth, as we talked about, splits up as x squared, x squared. So when we see this, remember, it's a squared minus b squared equals a plus b. Oops, that's an x. I want a plus b, and a minus b. Okay, so we just identify our a and a b. In this case, our a is 4x squared. And then our b is going to be 9. Okay, so I just follow the pattern. So I'm going to say 4x squared plus 9 and 4x squared minus 9. Now, once again, it seems like we're done, but we're not. We've got one more piece to deal with here. This one splits up because it's another difference of perfect squares. So we're going to bring down our 4x squared plus 9, and we're going to split this one up as 2x plus 3 and 2x minus 3. Okay, so our final answer is down here at the bottom. That is super messy. I apologize for that. Okay, hopefully you're following along there. Should be, I mean, it's at least clear. Okay, so we're going to split up the 4x squared minus 9 into, it's a difference of perfect squares, 2x plus 3 and 2x minus 3. Okay, our next case is factoring by grouping. So when we do factoring by grouping, usually, but not always, we can kind of focus in on the first 2 terms here and the second 2 terms. So I look at those as kind of separate problems first, okay? So the first 2 terms, when I look at 3x to the third plus 9x squared, I'm looking for common factors first. So I notice they're both divisible by 3 and also by x squared. So I'm going to kind of do backwards distributive property. And I'm going to say that's going to be an x plus 3 left over. Okay, because when I multiply that times that and that, I get back to the original. Okay, so I've got that piece done, and then there's a plus in between. So we're going to pull that down. Plus, now I'm going to focus in on these 2. What's in common? Well, there's a 4 in common. Let me back up a little, get rid of that circle there. Okay, there's a 4 in common, so I'm going to factor out a 4, backwards distributive property. I'm going to say x plus 3. Now, what you should recognize at this point is that we have a common factor of x plus 3 in both of those terms. So we factor the x plus 3 out, and then we say what's left over? Well, that and that. So we're doing 3x squared plus 4. And we're done. That's our factoring by grouping for that case right there. Again, you're looking for the common factor between the first two terms and the common factor between the second. Do backwards distributive property is what I call it, and you come up with a product. Notice what we've done. We've turned a sum into a product. These things are equivalent. They're equal. Okay? Both equations from beginning to end are equal. This product one is a lot more helpful for finding x-intercepts, as we'll find out in the future. Okay, so now let's look at our last example on this page. This one, the first step is kind of already done for us. You can see the common x minus 3. Boom, boom, and boom. So we factor out x minus 3, and we say what's left over? Well, I've got an x squared plus 2x minus 3. Okay, at this stage, we're going to stop there, and that is factoring by grouping. Okay, our next case is difference and sum of perfect cubes. Kind of looks like the perfect squares one we did, where we had a squared minus b squared. Now, in this case, we can actually do a sum and a difference. So we're not limited to just the difference of cubes. We can do the sum of cubes as well. And at first glance, these formulas look like they'd be really hard to memorize. But after you do enough problems, they're really not too bad. So we're just like we did the difference of squares, we're going to start with identifying what a and b is. So we know this is a difference of perfect cubes. Think about this splitting into 3 parts. X squared times x squared times x squared would give me x to the 6. 27 is 3 times 3 times 3. And so when we identify a and b, we're going to say a equals x squared. In this case, b equals 3. And don't worry about any of the others. Don't worry about the signs or trying to match it up. Just follow the pattern that's given to you right here. I'll highlight that for you guys. So we're going to just highlight. We're going to follow this pattern right here because we have a difference of cubes. Okay, so this one factors. It's x squared is a minus b, which is 3. And then we're going to do a squared. Now, a is x squared. So what's the square of that? Well, that's x to the 4th. And then we're going to put a plus. And then a times b is going to be 3x squared because it's x squared times 3. And then we're going to do b squared. Now, b was 3, so we're going to put a plus 9 there. And now we have this factored. This may factor right there a little further, but we're going to just kind of stop just because we're just doing the general pattern here. Okay, so this turns into this expression here. Okay, so again, we just followed the pattern. Let's do another example over here for the sum of cubes. Okay, so we're going to look at this and say, let me get rid of this first. Okay, so we got that out of the way. And let's just focus on this piece right here. So think about 125 as 5 times 5 times 5. And x cubed is x times x times x. So they qualify as perfect cubes. And 216 is 6 times 6 times 6. Okay, so I'm going to write over here to the left. We're going to write down what a equals and what b equals. So we can see that a is going to be 5x. It's the cube root of 125 and the cube root of x cubed. And then our b is going to be 6. Okay, so I'm going to get this stuff out of the way for us. Okay, we're just going to follow the pattern. Again, don't worry about the signs except for in the formula. You're only just kind of following what's right here in the formula, right there. Okay, so it says that this should equal a plus b. In this case, a is 5x, b is 6, and then we're doing a squared, which is 5x squared, which would be 25x squared. Make sure you're squaring the whole thing, not just the x. And then we're going to use a minus sign. A times b would be 30x, and then we're going to do b squared, which would be 36. And that's how we do the sum of cubes. I always remember the formula this way. So as you look at this, the plus part starts you out with a plus. And then you have a minus right there. Each formula has one minus sign in it. Whereas the difference of cubes starts with a minus, and then that middle piece is a plus. So these are all pluses over here. So again, if it's a difference, it starts with minus, and then they're all pluses. If it's a sum, it starts with plus, and then one minus sign in there. Okay, so thank you for staying with me on this long video. We got one more example to look at. Students get a little befuddled sometimes by this. They go to try to use the diamond in the box, and they realize when they get to the rectangle, there's just too many options, and they can't figure out what to put where. And the reason normally is because students did not factor out a common factor first. If I look at this whole string here, I notice that it's all divisible by 5. So I'm going to write 5. Let me get a little room here. Get a little bit, right, a little too large there. So I'll run out of room. So we're gonna factor out of 5. So we're gonna say 5 times x squared minus 8x minus 25. No, that would be 15. So minus 15. Okay, and how did I do that? Again, I'm just thinking about factoring out of 5 out of here. And what do I have to multiply to get back to the original answer? Okay, so now that we have our common factor out, in our final answer, what we're going to do is we're going to bring the 5 down because it is part of the factoring. So our final answer is going to look something like this. We're going to say, in this case, we're going to notice that we factor out of 5, and we're going to end up factoring the part in the parentheses here. So it's a trinomial, and this one actually factors. So I'm talking about this piece right here. So now we could use the diamond in a box, but when it's x squared, we know it's going to split up x and x. So let's take the shortcut of saying two things that multiply to negative 15, but add to the middle term of negative 8. And so we just kind of think about factors that might do that. And in this case, okay, great. As I set up this problem, I'm going to have to just change it just a touch. I've gotten through the 17 minutes of video. I'm not going to change it. So when I realized there are not two numbers that multiply negative 15 but add negative 8, what I meant was a plus here. So we're going to change that to a plus and work our problem like that. Let me make that a little bit more clear here. So this is a plus. I'll do a white here. So we have plus 75 and plus 15. So two numbers that multiply to positive 15, but add the negative 8. And that's what I meant to come up with this problem. Okay, so we have an x minus 3 and an x minus 5. Because negative 3 times negative 5 is positive 15. And when we add negative 3 and negative 5, we get negative 8. So now we have this thing completely factored right there. But notice it's so much easier with with factoring out the 5 first. We didn't even need the diamond in the box. If you started the diamond in the box, you would get 5 times 75, which is what? That's 300, 375. And then you have to come up with some crazy numbers in terms of what works there. Again, factor out the common factor first, and that's helpful. Okay, we covered a lot of factoring problems. All those methods can be used in different ways and in different orders to get to the answer that you're looking for. Hopefully that helps. Have a great day.